Hi everyone, today I'm going to present our work Elevator, a benchmark and toolkit for evaluating language-augmented vision models. This work is from Microsoft, UW-Madison, and UCLA. With recent vision language models like CLIP, it is possible to build computer vision systems that can not only perform well on standard IC and OD datasets, but can also easily transfer to many other real-world scenarios. However, it has several challenges in measuring their performance in the wild. Different models may report results on different datasets, and model adaptation details are often not fully available. To better ensure fairness and transparency, we built a platform with diverse computer vision tasks and an easy-to-use toolkit, Elevator. In terms of data, we collect 20 IC datasets and 35 OD datasets. As human, we can add node to make clarifications for a new task. To mimic the spirit, we add 3 types of external knowledge to all visual concepts in all datasets to provide richer semantics in the form of natural language. Compared with existing benchmarks, Elevator covers many task domains enriched with external knowledge and allows task-level evaluation with any shot. We also introduced a software toolkit to ease the process of onboarding new vision language models with 2 main features. First, automatic hyperparameter tuning to reduce human labor and ensure a fair comparison between models. Second, a strategy to adapt vision language models for image classification. Previous works, including the original CLIP, abandoned the pre-trained language encoder for model adaptation and randomly initialized a task-specific head. We argue that it does not leverage the full power of the vision language pre-training and can significantly hurt the model's performance. Instead, we propose to initialize the linear head using the language encoder output to aggregate both power of the pre-trained language encoder and downstream language specification. We compare with different initializations for both linear probing and fine-tuning. Our proposed language initialization outperforms the baseline random initialization significantly for few-shot settings. Notably, we show that even with very few shots, like 2 shots, both our linear probing and fine-tuning outperforms the zero-shot CLIP. We report many well-known methods as baseline results on both language-augmented approaches and language-free approaches. Language-free approaches are models like VIT or MIE with no language information used in pre-training. We report the average score of 20 image classification datasets under different shots. Surprisingly, we find that some model performance ranks differently from previously reported results. For example, MAE is worse than MoCo V3, self-supervised learning is worse than supervised learning, and it turns out that vision language model CLIP performs the best. Note that our conclusion is obtained using the automatic hyperparameter tuning toolkit and a simple data augmentation for all models to ensure a fair comparison. To encourage the diversity and inclusivity for the community, we encourage reporting results in 2 separate tracks. The industry track aims to evaluate the scaling success in data and model, while the academic track has a limited public pre-training dataset, aiming to encourage innovations of research idea and methods. With our benchmark, we see language-augmented models are better than language-free models with a better recognition accuracy and a zero-shot task transferability. We also recommend 3 different playgrounds based on the benchmark to accommodate different research efforts in the community. First, sample efficiency. Transferable models should achieve good performance with fewer training samples. We recommend zero-shot and few-shot settings as a quick and cheap setup for teams with less compute resource, when pre-trained models can benefit the most. Second, parameter efficiency. We recommend few-shot settings to study models' parameter efficiency, where the best performance requires an optimal number of trainable parameters. Inspired by natural language processing, there are many parameter-efficient model adaptation methods for vision language models. It will be valuable to compare with them in the same benchmark suite as well. Third, benefit of external knowledge. On the knowledge-augmented models like K-Lite, adding both Wiktionary and GPT-3 knowledge can improve the performance. Even for the knowledge-free models like CLIP, adding external knowledge can improve models' adaptation performance. Based on these results, we hope to encourage more advanced knowledge-aware prompting techniques. In conclusion, Elevator is a benchmark and toolkit for evaluating vision language models with 20 IC and 35 OD datasets. Please refer to our paper, leaderboard, and challenge page for more details. Thank you.